Yes, good afternoon, class. I am audible. Yes, please let me know I am audible to you or not.
Yes, sir.
Yes.
Okay. So, welcome to Cisco Packet Tracer class. Just hold on for a minute. Let the software start. Then I will continue. Meanwhile, students, if you have any doubt, you can ask me. If you have any doubt regarding Packet Tracer, you can ask me. Right? Any sort of doubt, any kind of doubt you have, you can ask me. Yes, here we start now. Now, I hope you can see my simulator, right? So, in the previous session, I have talked about different modules which is there we have in this, right? So you can see we having sub modules over here, right? And we have talked about that how one device is connected with another device, right? What is the role of real time and simulation, right? So I just want to show you this one of a simulation that I just want to show you. So what I did is I have selected one of the switch from this sub module over here in the left hand side. You can see over here. So simply you have to click it and drop it on the workspace. So this is your workspace, right? And one more we will take, that is a hub over this side, right? I just want to show you the working of switch and hub in an animation or in a simulation mode, right? Whereas I also try to show you that which device is working on which layer, right? So let's take another device, that is router. So these are the three intermediate device that we are used to connect with our nodes, right? So this is our PC1, this is our PC2, 3, 4, and this is PC5 and 6, right? So we are trying to do this network. This is one network where we can see now we are going to connect it with the cables, right? So I'm just simply trying to connect it with this one in this way, right? And these two, right? So this demonstration will let you know that how devices are communicating with each other, right? And even you will come to know on which layer these devices are working, that we are discussing in theory lecture, right? So let me first tell you that this is a hub, right, which works in layer 1, physical layer, right? Please remember this part. This is your device switch, right? And it works in layer 2, which works in layer 2, and which is data link layer, right? Data link layer. This is very important. Please remember this part. And finally, what we have is router over here. So router is your network device. So it works in layer 3. That is your network layer, right? We call it network layer. So now in this experiment, you will see, you will learn that how this devices, intermediate devices, they are communicating, right, with the PCs and all. So talking about hub, it perform broadcasting, right? So here broadcasting will be performed, right? This is how the message will be disseminated to the end nodes, right? This is one end node, this is end node, right? So how the communication will be possible using hub, and hub follow the strategy of broadcasting, right? And in the same manner we having switch over there, right? So in this, for the first time only, until the ARP is not set, what it will do, it will perform broadcasting, and then there will be a unicasting, right? Unicasting. And talking about router, you can see it also, it perform unicasting and broadcasting again. So unicasting is also done, right, to the network in this also, right? So talking about now one more thing, that is collision domain. Please remember all this difference. Collision domain is always single over here. That is one. In this collision domain, we have multiple collision domain. Multiple collision domain, right? So we want more collision domain. That is a better option, and more efficiently we could able to communicate. Whereas in case of single collision domain, because that collision domain basically talks about the medium, right? Share medium. So all the packets they are traveling through that share medium. So the probability of getting collision will be higher in case of single collision domain as compared to multiple collision domain. So this is a better choice. Multiple collision domain means it is a good part of this thing, and which basically leads to less collision, right? And which basically leads to multiple device to communicate at the same time, whereas hub does not allow this thing, right? But we are saying that hub is a better uh, than switch in some cases, because in the sense of its cost, right? So cost is less. That is the only point why that hub is still we are available in the market and people are using it, because somewhere in a network when the traffic is not so heavy, or you can say we don't have multiple more devices to connect, right? So in that case we are not willing to invest so high, right? Like switch and router, that demands uh, more cost, right? Whereas hub demand less cost. So this is less costly, right? So that is a good, that is the only advantage that you can see in this case, hub, as compared to switch. But talking about security level, it has no security level, no secure. Hub is not secure. So I try to cover all the aspects as much as can possible. And if if left something, then please you can tell me. Okay, over here switch, they are secure in a sense because we are performing unicasting, we are not performing broadcasting. Secure means they see what is happening, message is copied and broadcasted to each and every node. So every node is receiving, and where node is capable of rejecting the packet. Now think if that node for whom that packet is not actually, but message is delivered, now that node has rejected in that manner, it okay. But if that message is not rejected, it's accepted, okay, yes, I am the destination. Now you can say that in that way intruder can easily get that message, right, which is not intended to be delivered to that node, right? So in that sense we are saying that hub is not secure, whereas switch is a secure because it perform unicasting, right? So it is secure. So whereas router is also secure, right? So yeah, it is also performing unicasting. And not only collision domain that is over here, there is one more term that is known as broadcast domain. right? So the broadcast domain is also single in this case, right? Broadcast domain is single. This is a new term which I have not discussed in lecture, but now I am telling you the broadcast domain, which is single in this case, hub, and in case of switch, the broadcast domain is also single, right? Whereas in case of router, we have multiple broadcast domain. So router is that device which provide multiple collision, multiple broadcast domain, right? So these all are the important difference between all these intermediate devices. Now we will see a animated animation of how packet get traveled from one source to the destination in all this respect, right? One by one we will see. So if you can, if you want a screenshot, that you can do that. And all of you, please mark your attendance by writing present in the chat box. I will come in a second, just taking a screenshot. And if you have any doubt, you can ask. So these are all about devices. These are the three devices that we are using for the entire understanding of the networking, that is switch, hub, and routers, right? So now what I will do, I will assign a functional port, right, to all the devices. So how we can do that? Let me clear the screen for you people. And now you can see how I can assign a functional port by giving the IP address over here, right? So I have two options, IP version 6 and IP version 4, right? So IP version 4, now suppose let's take an example of 10.0.0.1 with subnet mask 255.0.0.0, right? And this is talking about number of bits which we are using for network address, right? 255. So you can see we have 4 octet 255.0.0.0. So we are only considering the first octet, right? So that is this is how it is, 8, 8, 8, and 8. So 2 raised to power 8. That's why it is 255, since we are starting from 0. So and the next 3 octet is 0, means we are not considering for the network address. These are the host address, right? This is of class A. So we are considering the first octet 255, since the first 8, you can say, see over here, right? This number out of 32, the first 8 bits are consumed for network address. This is what this signifies, 255, right? Next to, if we have another 255, let me show you once again. If we have another 255 over here, like this way, now what I am saying, that the next 8 bit is also consumed for network address in that 4 octet, right? So 8 is consumed, 8 is also consumed, and the remaining 8 and 8, this is used for host address, and this first 16 bit is used for network address, right? So that's what it is explaining over here. Okay, so let me give this address to this PC, and over here also we are trying to give one more 10.0.0.3. Let it be 255.0.0.0, and then we are closing it. Now these are the settings that we did, and you can see there is a successful transmission. Just I will set all this parameter, and after then I will show you that how we can able to communicate in a simulation mode, right? Let me clear the screen for you, and then I will come back. Okay. Okay. So here we have next IP. Now consider it 10.0.0.1, and we are considering 255.255.0.0, right? We'll consider it 4, like this way, right? Similarly, in this way, 10.0.0.6, 255.255.0.0, and like this way, right? Now what we will do is we will check that network is successfully. You can see over here. Okay. So I'm just making it more visible to you, like this way, right? Now coming to the router part. So you will see how we can configure router also. So before configuring router, what we need to do is we need to assign the IP address. So 10.0.0.10 or 12, suppose 255.255.0.0, and then we will close it. Similarly, we will do for this thing. That will be 255, sorry, 10.0.0.14, 255.255.0.0, right? Like this way. Now, what else we need to do? You can see we have to go to the interface. Now we have to, first of all, we have to find the interface, that is 0/0/1, right? So in 0/0/1, we have to turn it on, and then we have to set the IP 10.0.0. Something around 16 and 255.255.0.0, right? Similarly, over here we have this one. This is an interface of 0/0/0. So we will go to 0/0/0, turn it on. Then we will set the IP like this way, 18 and sorry, 10.0.0.19, which we have already given to someone. That's why, let me check. 12, oh, okay, already given, right? So 12 is there. This is the 12/16. You can see /16 basically signifies over here. You can see fast Ethernet 0 up 10.0.0.14/16. This is /16 means CIDR, classless inter-domain routing, which talks about now it is no more classful. It is now classless. Means now according to the rule, we are using class A address. And in class A address, what we are saying the first octet is occupied for the network address. But what we did, we also occupied the second octet, which is basically in class C. So now this is done for supporting subnetting, right? So when we are dealing with subnetting, we borrow the bits from the neighbor octet. So we did that, and that's why you can say that if in this you can see that it is coming /16, 10.0.0.14/16. It is coming like this way, right? Now I'll just make few more configuration, and then my device is ready for communicating. So it is 10.0.0.0 only. So I will set this IP address only, this network address only, right? And you will find now we could able to communicate, since this is a first time in router, it always there, right? Let me check. Now the problem is, again it is not coming. The problem is because we have not set the gateway. So what is a gateway? If you remember, 10.0.0.16, right? Ten dot zero dot zero dot 16. Similarly, over here we have Okay, we have not set this interface, and this interface is 0/0. So what we have to turn is 10.0.0.18. Just hold on. This is gigabyte 0/0. Gigabyte 0/0. Turn it off and on. Now I'm setting this 10.0.20. Now let it be. Overlapping with 10.0. No, I have not assigned this address, but still it's creating an error. Now what is an error? Let me see. This is 0/01. 0/01 is not. It is 16.10.0.0.16 to 55.0.0.0. Turn it off. Again, restarting the port by clicking it. And now this thing is okay, right? Now over here, 10.0.0.0. This is 10.0.0.1. So 0.0 is not assigned. So let me turn it on and then give me, let us give this address to it. There is an internet and someone was not entered. Right? 10.0.0.0, sorry, 1 and 255. Okay. Like this way. And let me connect it with 11, and this will be different network, so it will be 11 now, right? And let me give it the subnet mask 255. Okay, now it's done, right? Now let me check it. So, yes, it's working. Let me check on this side also. It's working or not. So it's not working. Let me do it again. From this to this PC, successful. First attempt is always failed in router. So don't get worried. Might be there is an issue, right? So what we need to do is now we need to set the routing information protocol. That is our routing setting. Then it will be ready for communication, right? So let's do that. Now, as we have set, right, it need to work now. Let me check. This is 11.0.0.1. This is 10.0.0.16, right? This thing is working. This thing is working, right? So over here, this should need to work. The gateway is not set. The gateway address is how much? 11.0.0.1. Let's check the gateway if it is set or not. Not set. 11 dot. So let's set the gateway 11.0.0.1 and then save the setting and come out from this. Now let's try this whether it's working or not. Yes, we could able to transmit from PC4 to router and from router to PC5. Then it will be from the twin dish. Yes, now it's working, right? So see the significance of gateway. Otherwise, it will always show that packet could not able to transmit. Now we have configured all these three, right? Any doubt? We have configured layer 1 device also. This is your layer 1 device. This is your layer 2 device. This is your layer 3 device. And this is how we are going to see in the simulation mode now one by one when I will transmit a packet between these two from here to here, right? You can see successfully from this, and right, this will not able to transmit, right? But yes, one by one we will do that and you will see how it will be. So let's try it from here to here and then you can see in simulation mode. I'm trying to start the simulation. So first packet will come to the router, right? And then router will forward it to the PC5, right? So there will be acknowledgement and there is a successful delivery of packet, right? So you can see how this is how the communication completed, right? Now let's check it out. Since it is a router, so let's check it out. Router is there, and we having a router over here. So you can see that up to which layer the packets are exposed. They are up to layer 3 exposed, right? You can see IP header internet protocol, that is 10.0.0.14 with this to 11.0.0.12. So up to, so that's why it is said it is layer 3 device, right? In this manner you can see, right? Similarly, now we will check for hub. Right. Now, one more thing that I want to show you, right? So for that, what we will do is we will add one more PC. Then only it will make you understand that how packets are delivered. Unicasting and the concept of collision domain that we have studied in the class, that will be much easier for you to understand over here, right? So what I will do, I will connect one more node easily, and you can also do it at your end, right? There is a problem with this. Why so? Because this does not have a fast Ethernet in it. Let me check. Yes. So what we have to do is, you can see you have to go to this one module, right? And we can see in this that we don't have RJ45 connector port. So we will try to copy it. We will try to, yes, in this we have fast Ethernet. This is your fast Ethernet, right? So we will try to add one, turn off the power. So we'll turn off the power from here like this way. Once the router is turned off, you can see even the lights will turn to red. Network is now not available. So we'll simply, this model is not compatible. The problem is coming with this one. You need to make it. Let's check it out. Now from here, we can simply drag and drop the modules and we can have more ports in the router. This is how we can do that, right? And let's turn it on. Now we have our machine. This router we have turned on, right? So depending upon the need, we keep on adding the modules, right? Whereas this problem will not come in this, right? You can see we can simply able to connect with more interfaces are there in layer 1 and layer 2 device. Layer 3 device is limited with that, so that's why it is always connected with the use of hub and switch, right? So that with then we not required any such port, right? Let me check it out again. Yes, now you can see we can able to connect, right? We could able to connect with this. Now I just want to show you that this is the IP which we have given, that 10.0.0.14. So I will set it with some other IP over here, that is 10.0.0.19 to 55, and there is a gateway address, right? What is that gateway? I have to check. We have set the gateway 16, right? We have to very particular about the addresses, otherwise your communication will not be complete. 10.0.0.16, it will always be failed. So you will see now in few after few minutes, the port will get started. And now you can see how many gigabits are there since we have installed the modules. So in which we have set the now the problem is when we have reconfigured the router, the settings we did is also erased. Now you can see the router setting has been erased because we have turned it off, and even we have installed the new module, right? And due to that, settings has been removed. Please remember this part also. This is a learning whenever you are trying to do. So that's why we are saying wherever we are running, system is running, we never make any changes in a live environment, right? We test on some other environment and then we try to do that, because if some kind of issue or problem arises, then it is very difficult, and even whatever we have, that also will get lost, right? So not a problem, not an issue, no worry. We will turn it again to on. Simply we have to remember that port number which it is, right? So it is connected with 2 gigabit 0/0/1. So this is that one port, and which need to be connected with the 10.0. Something around 16 we have, that is the gateway address we have set or not. Let me, this is the gateway, the same gateway address we have to give, right? Gateway 16, right, correct. So that will be the 16 only. You can see now it is turned on, right? Similarly over here, what we will do, we will assign this 11 dot something that we have set 12, and gateway is 11.0.0.1. So we have to turn 0/0/0, and we have to turn it on, and 11.0.0.1, and the subnet mask will be taken by itself. And in this manner, now this router is ready with these 3 devices. You have seen that how more modules could be added if it has limited number of ports. Now let's check the animation, how it works, right? So as I'm telling you, it is performing unicasting. So that is what we are saying. We are looking for that thing, and there are some issues that we need to, might be this interface need to be given an address which is not given. This is an interface of 10 0/0 0 1/0, and this is what the gateway we have to give something 10, right? So what we will do, we will assign this address to this port 0/1/0, 0/1/0. We turn it on, right? So we will, that is not working. Just hold on. Right. Yes, class, if you have any doubt, you can ask. Right. Till then, we can check this one. This is your hub, and that is connected to 2 devices. Let's start the animation. We'll say hub is always performing broadcasting. So it will copy the packet, and then it will forward it to both the devices. Now that's why security is not there, because now the copy of a packet is with every node. So you can see what will happen. There will be a rejection, right? But what if a node over here has accepted this packet? Now that intruder, think of this thing, if there is an intruder, then that packet could be easily hacked. So that's why in that sense, we are saying that hub is not a secure device, right? As compared to now, let's check it out in which layer it is working. For clicking in hub, you can see it is a layer 1 device, fast Ethernet. It is not exploring. We are not checking the packet above this layer. In this hub, we are making use of the frame or the data up to layer 1 only, right? We are not moving to the upper layers, because this is layer 1 device only. It can only understand up to this layer, whereas router is a layer 3 device which is dealing with IP addresses, right? That is the network addresses. and on that it is working, right? So which is basically for forwarding the packet to understand the multiple network. So that's why router come in picture when we are having different networks, right? So for that reason, we need a router, right, over here. Whereas in case of switch, now let's check it out for the switch. You can see how it is working, and we will have animation. So let me delete the previous scenario and then check it out how, oh, sorry, there is no functional port. We have only attached that and not assigned the IP, I think. So 10.0.0.23, 255.255.0.0, and then we will save the settings, delete the scenario, again pick the message, and then try to send it. But like this way, you can see packet is first forward to the switch, then it will be forwarded to the both devices, right? And then the response will come. This is for the first time because till now the address is not copied with the switch. So that's why broadcasting has appeared, right? Now again, if that thing has happened, you will see now it will perform unicasting, right? So that's why it has multiple collision domain. Now it will not broadcast the packet since now the information is with the switch, the mapping of IP address and MAC address is done. And because of that, then ARP protocol is set. Now you can see using command line interface, when you will go to one PC and click on command line interface, you will check ARP, you will see it will show you the addresses over here, right? So this is the MAC address, the physical address, and this is the associated IP address. Now, if I clear all this thing, if I delete this thing again, you will see it will perform broadcasting and then unicasting. This is 5 to 10 marks question from lab or into MST point of view, right? Now again, I am doing the same task. You will see again, switch will perform broadcasting because now switch does not have that mapping of ARP. So once the first packet is delivered, then switch will maintain the record. So that's why it is said in a switch, it has a intelligent memory. It has a memory, or that's why it is said that switch is intelligent than hub, because once it is done, after that, now there is no need to broadcast again. And since we have seen that we have deleted the entries, you can see ARP-D, what it does, it has removed all these entries, right? Now let's check it out on. So this is the command ARP-A. So what you will see, since I have communicated with only the PC node to this PC7, so that's why that entry has been added in the ARP table. Now the same thing I will do for PC1. Again, you will see what will happen. Now I am just deleting the scenario and doing PC0 to PC1 and starting the animation. You will find that it is forward the packet again broadcasted because it does not know about PC1, right? So that has happened. And now again we will see this command. Now you will see since it is not completed successfully, let it the acknowledgement come back, and now all the information is recorded in the hub, in the switch, in that memory. Now you can check that entry of ARP over here. So when we will do ARP-A, you will see now the